Hi, my name is Asira Saraswatula, and this is my report on Lab 1 regarding the amount of excess charge on an ordinary object. The purpose of this lab is to determine the amount of excess charge of tape by calculating the force it exerts on a second piece of tape. This can be done by creating two charged tapes, with one taped to a stationary object and the second brought closer to the first stationary tape and measuring the float distance of the stationary tape. The fundamental physical principles that this lab exemplifies is Coulomb's force law for point particles and conservation of charge. Coulomb's force law, shown here, allows us to determine the electric force exerted on one point particle by another, given the distance between the 2 point particles and the respective charges. Meanwhile, the conservation of charge states that the net charge of a system plus its surroundings cannot change. The assumptions that can be derived from these physical principles will be discussed later on. The first part of the lab requires us to create charged tape and observe the interactions that it has with charged and neutral objects. The table indicates the different objects which interact with the tape and my expectations and observations of the tape interactions. This final interaction with the charged plastic pen allowed me to conclude that the tape is positively charged, since it is known that a plastic pen becomes negatively charged when rubbed with cotton, wool, or hair. The following part of the lab required us to determine the amount of excess charge on the U-tape. The setup is as shown to the right, where the stationary tape B is the system, while tape A is mobile and a part of the surroundings. 3 assumptions can be made regarding the setup that will allow for us to perform the necessary calculations later on. The first assumption regarding Coulomb's force law is that the U-tapes are point particles with the forces exerted at a single point at the center of the tape. By making this assumption, we can use the formula presented earlier to calculate the electric force exerted on one tape by another. The second assumption that can be made is due to the concept of conservation of charge. Assuming that tapes A and B are the only components of the setup that are charged, due to the conservation of charge, the two tapes must have the same net charge. The final assumption is that air resistance is negligible in this particular system. From these assumptions, we must turn our attention to the system itself, stationary tape B. Since the momentum of tape B is 0, the net force of tape B must also be 0. We assume that the only two forces acting on tape B are gravitational and electric. Thus, the gravitational force and electric force must be equal. The measurements made for this experiment include the tape length, tape mass, and float distance between the two tapes. From the tape mass, I was able to determine the magnitude of the gravitational force, which is equivalent to the electric force magnitude. By rearranging the equation, the formula for charge can be calculated as shown above. With our measurements, the charge is calculated to be 7.06 times 10 to the negative 9th coulombs. To determine the number of excess electrons, we must simply divide the charge by the charge of a single electron, and the number of excess electrons is shown here. The number of atoms can be determined by dividing the measured tape length value by the diameter of an atom, which is 1 times 10 to the negative 10th. And then finally, to determine the ratio of atoms to excess electrons, we simply divide the number of excess electrons in atoms by the total number of atoms. When modeling the system on GlowScript, I first listed the constants included, all measured quantities, charges, and any scale factors. I then calculated the gravitational and electric force magnitudes. I then created 4 objects, 2 point particles that represents tapes A and B, as well as 2 arrows representing the electric and gravitational force. The program calculated the charge of the tape to be 7.06 times 10 to the negative 9th, and the number of excess electrons to be 4.4 times 10 to the 10th, as calculated in the previous slide. The link to the GlowScript code modeling the system with the corresponding forces will be in the description below. To reiterate, in order to estimate the charge of electrons, it was necessary to make several assumptions derived from the physical principles previously mentioned. In performing this experiment, I made the assumption that air resistance is negligible, the tapes are point charges, and the net charge is equal for both tapes. After collecting the data, I used Coulomb's law and the law of universal gravitation to calculate for the charge of the tape, which I determined to be 7.06 times 10 to the negative 9th coulombs. Thereafter, I calculated the ratio of atoms to excess electrons to be 1 to 24.675. The computational model of the system is an accurate representation of the experimental results. Several questions arose in performing this experiment, and one of those questions is, if electrons had a positive charge and protons had a negative charge, how would the interactions observed be different? And I believe that the interactions between the tape and the other charged/neutral objects would essentially be the same, since there would still be repulsion between like charges and attractions between opposite charges. And the second question that arose in performing this experiment is if it's important to minimize the contact between the tapes and other objects, and why. And I believe that it is important to minimize the contact between tape and other objects because it will prevent the tape from engaging in electric interactions with such objects.